Technical foul, number 11, on geometry 5B. You get another one, you're out of here. Let's go to the notes. Chapter 11.3. Here we go. Don't get kicked out of the game. Okay, you guys, here's our 11.3 notes, arcs and chords. I'm hoping this is a little quicker than our last set of notes. The last section was a little long. So here we go. In circle P below, each chord joins 2 points on a circle. These 2 points. Between the 2 points, an arc forms along the circle. This. By theorem 11.3, AD and BC are congruent because their corresponding central angles are vertical angles and therefore congruent. So it's showing since these angles are vertical angles, that means these arcs are going to be congruent as well. Okay? Can we show that AD is equal to BC? Can you prove that the two triangles, APD and CPB are congruent by side angle side? Therefore, AD and BC are congruent. The following theorem describes the relationship between two congruent minor arcs and their corresponding chords. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So, arc AD is congruent to arc BC if and only if this is congruent to this, the chords. Okay? If they're not, we can't say the arcs are congruent. All right, let's move down here. The vertices of equilateral triangle JKL are located on circle P. Identify all congruent minor arcs. Okay, guys, equilateral triangle, that means all of our sides are equal. It also shows us that all of our angles are equal. So, if we know the sides are congruent, then we know that the arcs that they create are going to be congruent as well. So, we would say the minor arcs that are congruent are going to be arc JL congruent to arc KL congruent to arc KJ. Okay? Alright, and the bottom one. The vertices of isosceles triangle XYZ are located on circle R. If XY is congruent to YZ, identify all congruent arcs. So I drew a picture, triangle R, and I have an isosceles triangle, meaning two sides of the triangle are congruent and the base angles are congruent, and one side is not. So I'm going to draw this, and it's, let's see, Y, X, Z. They said this side's congruent to this side. If we know that, these angles are congruent. So this arc is going to be congruent to this arc. Can't say anything about this because this angle is going to be different than these two base angles, okay? So the congruent arcs are going to be arc X, Y, congruent to arc ZY. Okay? All right, this next theorem is going to help us for the next page. In a circle, a diameter, this, bisects a chord, this, and its arc, this. If and only if it's perpendicular to the chord. See that? It'll make more sense on the next page. So let's keep this theorem in mind. Perpendicular, it bisects the chord and the arc. Okay, here we go, next page. Okay. If in circle P, PM is perpendicular to AT, telling us PT is 10 and PM is 8. It wants us to find this big thing. So one thing we know is that this chord will be bisected by this diameter. This is a right triangle, guys, so we can do what to find this last side? Pythagorean theorem. Awesome, whoever said that. Great job. You're amazing. So 10 is my C. So 10 squared equals 8 squared plus, and we'll call the bottom A. We do all the magic. Minus 64, minus 64. I think it's 36. Square root of 36 is 6. So we know this side right here is going to be 6, but it's asking us to find AT, which is this long segment. So 6 plus 6 is 12. So AT is 12. See that, guys? All right, let's move down to the next one. In circle R, it's telling us XY, this chord is 30. So we can automatically say this is split into 2 because it's bisected by the diameter. 30 divided by 2 is 15, so each side is 15. It's telling us RX, this side of the triangle that is created, is 17. And it's telling us this is parallel to the chord, and it wants us to find this small distance here. Guys, look, it's a right triangle again. What can we use? Pythagorean theorem. Oh my gosh. Thank you so much, whoever said that. That was amazing. Yes. Pythagorean theorem. So 17 is our C. We'll make 15 our B. And the small side will make A. Solve this. 15 squared is 225. 17 squared is 289. Subtract. We get 64 equals A squared. 64 squared is going to be 8. So we know that this side right here is going to be 8. So we can say the distance from R to XY, this distance is 8. So we're going to name it RZ. All right. Okay, let's move down. Find each measure in circle K. Alrighty. The diameter perpendicular to the chord. Check. It's giving us this side. What do we know? What happens when a diameter bisects a chord? It splits it into 2 equal sides. So if this side is 7, this side is also 7. But they want us to know the long one. So 7 plus 7, 14. AB equals 14. All right, the next one. It wants us to find this side, KM. We know this length is 6. This is going to be bisected because this radius, which even if we extended it would be the diameter, is bisecting the chord. So if this 16, half of 16 is 8. So our sides are 6 and 8. We don't know our C, our long side. So we can do 8 squared plus 6 squared equals C squared. 64 plus 36 equals 100. So a square root of 100 is 10. So we know that KM is 10. All right. Okay. All right. Down to number 6. In circle Q, KL is congruent to LM, the arcs. So if we know that this is split, that's perpendicular. These are congruent. So if it's telling us that CK is 2x plus 3 and CM is 4x, and these are congruent, we can set these two expressions equal to each other. So 4x equals 2x plus 3. minus 2x minus 2x. 2x equals 3. X equals 4, 1.5. Okay, for that last one. And then one more. Suppose, whoops, my thing is falling down. I have this all rigged, so I have books under this top piece, so just trying to make sure the video is not as blurry. All right, so it's telling us CK is 5x plus 9, and CM is 6x minus 13. That's perpendicular for this situation. We can set these equal to each other because when a diameter bisects a chord, it makes it into two equal segments. So 6x minus 13 equals 5x plus 9 plus 13 minus 5x minus 5x. So I get x equals 9 plus 13, 22. So I found x for each of these based on my theorem of the diameter bisects, if my diameter is perpendicular to a chord, it bisects the chord and the arcs. So there you go, guys. I will see you guys at Zoom tomorrow or whatever day this falls on, and good luck on your homework. See ya.